When I get home at the end of the day, I like to be home.
Oh,
I get way too
I think I left. Thank you. Thank you. Thank you. All right. I need eyes. I need y'all eyes up here. I need y'all locked in. We got today and tomorrow to finish up this unit test on Friday. I'll go ahead and tell you, we should finish the unit today completely, looking at the last lesson. We may need to take a little bit more time tomorrow, but the last lesson we're working on is just practice for everything that we have learned. Okay, so it's not adding anything new. Second, I need y'all to pay attention to this because I've realized that this bell ringer should address several misunderstandings that I saw in the homeworks, okay? So I need you lasered in, I need you focused, and getting... Pay attention. All right. And I'm going to talk about a couple other things, but eyes up here. So if you are finding the percent of data between given values, when is it better to use the empirical rule rather than calculating the z-score? And so I want to point this out. Do you use the standard normal curve for both? Or can you? Yes. So I want to look over here. Standard deviation. If you're using the empirical rule, do you need to know something about the standard deviations?
Yeah.
Yes. The 68, 95, 99.7 is based on what idea?
It's a full deviation, right?
Okay, so full deviations, right? So 1, 2, or 3 full deviations away from the mean. Do you need the standard deviation if you're dealing with z-scores?
Yeah.
What's the formula for a z-score?
M equals X. I mean,
Oh.
X
equals Okay, now, first off, I want to pause and I want to point this out. Remember, X bar and S are when you're dealing with samples, right? Those are statistics. Mu and sigma are when you have parameters for the population. But don't forget, these are the same formulas. It's just value minus mean divided by standard deviation. That's what the formula is really saying. That's a z-score. Because what is a z-score telling you? This is fundamental. What is a z-score telling you about that value?
How far away it is from the mean?
Okay, not just how far it is from the mean, how many standard deviations, right? Remember, the numerator tells you how far the value is from the mean, and this part tells you, gets in that idea of how many standard deviations that value is from the mean, right? A z-score is all about how many standard deviations that value is from the mean, which is why if the value is less than the mean, what type of z-score do you get?
Negative.
Negative. That's what the talk was kind of about. If the value is larger than the mean, you get a positive, right? So standard deviation, it shows up in both. All right? Yes, you can be more accurate, I will say, with z-scores. But notice the question was about when should you use empirical rule. Mean and standard deviation, I believe that shows up for both empirical rule and z-scores, right? Okay, so I'm going to look for, see if there's anything up here. Actually, there is, there we go. I see 2 or 3 up here that are correct. So let's number these. 1, 2, 3, 4, 5, 6, 7. I know this isn't everybody's answers, but which of those do you think, look through them, which of those do you think are best or most accurate for when we should use the empirical rule? I will say this, we already said no to 1 through 3. So let's do a voting. This says when we are finding percentages on, above, below, or between standard deviations. I'm assuming they mean whole standard deviations. What do y'all think? Is that when we want to use empirical rule?
Yeah. No. I don't know.
Can the empirical rule be used with whole standard deviations?
Yeah.
Yes. Or integer standard deviations, 1 or -1, right? It's within 1, within 2, within 3. So sounds pretty accurate. If the deviations are a full deviation away and not halved, can we use empirical rule in that case? Yes. It's better to use the empirical rule when you're trying to find information that is on or with the standard deviation. I'm guessing that still means add a whole or integer value of standard deviations. Okay? This is what I want you to focus on and understand. So actually all three of these first ones right here, or these 4 through 6. You use the empirical rule when dealing with integer values of standard deviations. So here's my mean. How many standard deviations does that mean from the mean?
0.
Right? Remember, that corresponds to a z value of 0. Be careful and be attentive. I know it's hard to draw the curve, but where should my one standard deviation be once I draw the curve?
Where it starts to drop.
Not where it starts to drop, points of inflection. Remember, it goes from concave down to concave up. So there is z equals 1. I use that same distance to get z equals
2.
And same distance again to get z equals. And it doesn't have to be perfect, but I do want you to try your best to get those points. Okay? So that's z equals,
-1.
and same distance again, -2, -3. And so if I want anything between integer values, I can use the empirical rule. But what if I want for a value less than 1.5? That's going to be like right here. Can I use the empirical rule then?
No.
That's what you need to understand. The empirical rule should be used anytime you're dealing with integer values of standard deviation. You'll use the z-scores to find the area under the curve or find the percent whenever you're not dealing with integer values of standard deviations. That's the defining mark between those. Now, I will point this out because some students use z-scores all the way through on lesson 2 homework. But, and I will say this, z-scores and the table, z-scores and the calculator will always be more what than the empirical rule? Accurate, right? But which one's going to be faster? The empirical rule. That's the idea, is that the empirical rule is faster, so if you have integer values for the z-scores or for the number of standard deviations away, use the empirical rule. But if you don't, that's when you would transition to the z-score. What are your questions at this point? I will say we're going to get more details with z-scores and practice with it within the last lesson, but what are your questions about empirical rule versus z-scores right now? None? Okay. I'm here for you. I just need you to ask those questions or talk within your small groups. All right. So agenda. First off, I want to point this out because I've been meaning to talk about this. The I am capable. Is it a little goofy? Yeah, However, one of the things, I'm going to start to add in at the end of class 2, one of the things I want you to understand first and foremost, I am an imperfect teacher. I am not going to say things the right way all the time. I am not going to always make you feel the best because, one, I'm always going to challenge you to be more because that's my job. If I don't challenge you to be a little bit more and to push more, then I haven't taught you and you haven't learned. If things are always easy, then you're not learning and growing. This is a constant reminder that I want you to have that even when things get difficult, you are capable of mastering it. Okay? I need you to understand that this isn't some goofy thing that I'm just like, whatever, like, I want you to say this. I fundamentally believe every single one of you are capable of learning and learning at high levels. And so I'm going to challenge you to do that. And that's why I want you to be reminded every day that you walk into class that you are capable. Say it with some enthusiasm. Come in with a positive mindset. I always try to come in a little excited, happy, energetic. I will say it helps when you get up at 4:40. I've already had 3 hours within the day, so my body's going. But come in with the right mindset. It helps. Okay? And trust me, you are capable. You're capable of amazing learning. Do what you got to do to make that happen. So tutoring and homework, I'm not going to call any students out because I don't think that they would like that, but there are a couple of students in here who have already come into tutoring, and they may have been lying to me, but I do want to emphasize that at least when they were leaving, they said, man, I feel like I understand this idea better. Okay? The tutoring is free. 4 different tutoring sessions every single week. come into tutoring if you're struggling with something. I want to help you. I want you to be successful. Because you are capable, but sometimes we need a little extra work outside of class. That's totally okay, and that's good. That's to be encouraged. Especially when it comes to homework. If you're struggling with homework, right? There's always multiple days to get your homework done. So if you try it 2 days out from when the homework is due and you come into tutoring and say, hey, Mr. Kinney, can you help me out with this? Everyone's gotten answers for free, but also they've learned how to do it better. Okay? Come into tutoring, take advantage of that. And I know some of us have work or we have other activities, flag football for some of the girls, things like that. But that is part of the reason why I also post videos on YouTube. I need you to understand that the YouTube videos aren't going to be perfect because, well, it's just our discussions in class and the notes on the board. If I were you and I were to watch the videos on YouTube, first off, all you have to do to find those videos, search my name. You search Nathan Kinney, it's the first thing that pops up. I guarantee, because I've done it multiple times. Okay? So you search my name, it'll be the first thing that pops up. Click on the channel and find the Algebra 2 playlist. The second thing, I just record the entire time of class. Don't watch the stuff that doesn't matter. Like, there's lots of time we all work in small groups, right? Don't watch that section, skip through it. And just focus on the sections where there's the whole class discussion about things and follow along with the notes, okay? And take notes. And if you take those notes, like if you miss a day, you take those notes, you'll be better prepared to come in to tutoring and ask questions. Or at least be better prepared to talk with your group about whatever. I'm trying to give you all the support possible because fundamentally, I know this. Not just I believe this, I know that you are capable. I'm going to challenge you to be more. Because I know how capable you are. Alright, I think that addresses everything. Oh, the other thing with homework. Please understand, I'm very okay with you having conversations and dialoguing, just like you do in class, when it comes to learning or trying to figure the homework out. But it has also already become very evident to me that some of us are just copying. I'm not going to call you out on it because here's the thing. It's only going to hurt you, but it's going to show within your understanding checks and things like that. And I will also say, like, on these homework assignments, the first one I gave out was out of 8 points. I'm actually only going to make it out of 7 because I know it's a little bit tougher for some of us, and even then I'm going to half it, right? So instead of it being out of 8, take whatever your numerator is, it's out of 7, and then half both those scores. Is that really going to impact your grade a whole lot? No. It's more of a learning opportunity than anything else. That's what homework is designed for. The one that's out of 10, guess what's going to happen to that score? And half it. It's out of 5. Okay? So it's not going to make or break your grade, but at the same time, like, try it for the learning's sake, not just to get it done. Homework is not one of those things that's designed to make your life harder. It's designed so that you get the practice. The other thing, the final thing I'll say is this. It's very obvious when we haven't just flipped back through the lesson. Okay? I don't think you'll get upset about this, and if you do, call me out on it, and I'll say I'm sorry. But Hudson did the homework. What did you use all the way through on that lesson 2 homework, though? Did you use empirical rule or z-scores? Z-scores. Right. Flip back through the lesson, because if you had gone back through the lesson, you would have realized that that lesson was only about what? The empirical rule, right? The lesson is there, your notes are there. Take advantage, go through the lesson that's before that. Notice if you do the homework and you flip back through the lesson before, that's going to help you study because it's going to force you to look back over your notes. Take advantage of that. Everything I do, even if it's imperfect, is designed to help you grow and learn. I promise, because I know how capable you are, but I also know that we need more practice. We're going to look at lesson 4, normal distributions and probability. This isn't going to change anything really, and I'll explain how, even though, have we talked about probability yet? We've only talked about, it's another P word, percents and percentiles, and we have talked about area under the standard normal curve. The probability is not going to change anything out of it, okay? So today is going to mostly be a practice day. If we have time, we're going to start addressing the homework. So the homework that you got back today, we're going to start addressing it. Tomorrow it's going to be all about the homework discussions and going over the understanding check, and then more practice if we have time for it. Okay? Questions, comments, concerns? Feeling good, Madison? Cool. Zaria, you good? You awake? It's okay, you can smile even though you're in math class. Okay, we're not. Anyways, moving on. So we're looking at lesson 4 today. This is, let me change the method of projection. So I don't have, no one's near that TV anyways, so I won't stress it.
What page is this?
That's what I'm trying to figure out. 45. M5-45 is the lesson that y'all are looking at. I have no clue why the name is the way it is. That it looks weird to me. Oh, thank you. I hate that. Tomato. I get it. I now get what they're trying to do. That's silly. So what they're trying to note there is, even though we're going into probability, it is no different than what you've already been doing. Okay. Do note, always look at your learning goals. So interpret a normal curve in terms of probability. Use normal distributions to determine probabilities. And use normal distributions and probabilities to make decisions. This is what we've been building up to this whole time. So, objective that I wrote, I just want you to be able to determine the probability of an event described by a normal distribution. That's it. And it doesn't change anything we've done already up to this point. So what I do want you to do is I want you to do this getting started. This shouldn't take us too much. Don't make it harder than it has to be. Work with your small group to answer parts A, B, and C. Which, by the way, I do want to point this out. I didn't give too much instruction, but what should you definitely do?
Talk.
Yes, talk, but also read your instructions. Don't look at me like I have no clue what I'm doing. If you haven't read the instructions, read those instructions and help each other make sense out of this. And let's get to work.
On average, they don't take
Why are you picking that off?
Stop, dude.
Them jackets are expensive.
Come on, quarterly. That's going to get all over my floor. Stop that. I'm putting in my work. And they're going to end up on floors. Let's get to work on this math. Come on.
Oh, yeah, well, this is 34. This is 234.
I got to figure that out.
Permit is 30.
between 100 and 125 just the probability. Is that still a percentage?
Okay, so you have it marked off. So what are you going to do? Use now so that you have that region marked off. Okay. So empirical. Why do you say empirical?
Let me see. It says the same thing.
So that is the empirical rule, but what allows us to use the empirical rule?
I'm gonna go with
It's one whole standard deviation, right?
Those are
That's what I wanted to
points.
recognize.
It's not in between the points. That's what you use to get it.
You're talking about using z-scores versus empirical rule? So which one are y'all going to use for part A? Let's get it going then.
Mr.
Yes. I assume you're going to say Mr. Right.
Yeah.
What's that?
You know how to do
Have
that.
it.
What's up?
One of those three numbers.
It's 60 something. 590.
There you go.
So we divide it. What we use those numbers or we just do 25?
I'm going to answer your question. Before I answer your question, have you talked to anybody in your group about it yet? Because there's one student at least that has already answered those questions. Collaborate and talk. And I'm not saying it's necessarily right or wrong, but I do want you to discuss and see if you agree.
So which
You're on that. Let's make sure we're working together and we're agreeing. What was your why? You said
He's not gonna like that. Yeah, we need a, we
No,
need
ma'am, we don't take an educated
No.
guess. What's your reason why? Here we go, because why? After 68, I mean, you use the empirical rule between 0 and 1 standard deviation, right?
Yeah, well,
How do I say these higher twenties?
I just say the percentage between 75 and 25, that's 68 using the empirical rule, and then I just divide it by 2.
Sure, that's a good explanation of what you did, right? So you're getting better at it already. Get better at it, get better at it.
Just right here, where the definition is 7.25.
I'll be second actually. Coming up here. Because I also have to
Yeah. Fifty is not, or 140 is not halfway. How y'all, what's your plan of attack for Bob?
Oh, it's no saying true.
Yeah, it's right.
You know what I'm saying.
It's just all that adds up.
I don't know why.
Plans of attack for Part C?
Yes.
Yeah. It's usually empirical, 75 on 25 to 68.
Can you do that?
To get all that.
Yes.
So all of these, these are.
I would consider it against. I would consider it because it. What rule are you still trying to enforce? Can you use it?
And all they want to know.
Right. We just discussed this. That's the only time you can use empirical. Not just that, there's something else. On the integer standard deviation. You've got to consider empirical versus z-scores. Go ahead and jump to part C for me. Yeah. Okay.
More than 140.
Whatever they ask you is
Y'all stuck on one of them? So that's a good question, right? So remember on the table, it's always going to give you the area to the.
Yeah, but
No. So like if you have your z-score, right? So this is one of the reasons why I would always draw it out. So if you have your standard normal, right? You have a z-score of what? 1.6. So 1.6 minus 0. That area on the table is always going to be to the left or to the side. On the table, the area is always to the right. We avoid what is to the. So how are we going to find it? So we need to be careful and know that the z-score table always gives the area to the right.
that's what I'm talking
So how are we going to find that top?
No, listen to my question. I asked you on the other side.
Very close.
I'm asking you on this side.
But here's the thing, 99.7 is only what's between 3 below and 3 above.
How do you know?
What's the percent for all of it? So it's 100 minus what's on the table, or really 1 minus that, right? Thank you. Thank you. Thank you. So there's a couple things I want to talk about. Z-scores, or not Z-scores, parts A and B. What strategies did we use on parts A and B?
subtraction.
Okay, let's go beyond that.
Empirical rule.
There we go. So that's the big idea that I want us to see on parts A and B. Why could we use the empirical rule? Emma?
We could use it because we're doing like standard deviations.
It's integer values of the standard deviations, right? Hold those integer values of the standard deviations. For example, when I look between 100 and 125, which integer values on the standard normal curve?
Ask your question again.
If when I look at A for 100 to 125, I'm looking between which integer values on the standard normal curve? 0 and 1. And so, what was the per area there?
34%.
Okay. Now, there's two things I want to talk about at this point. That is 34%. First off, does anybody want to push back on that? I've written 34%.
It's half of CC4, which is.
So we want to justify, right? Because
Hey,
half of 68% from empirical rule. And I saw Owen doing a great job with his group talking about that, saying we need to justify. But I do want to pause and I want to point this out, because this is important. That is not how we would write a probability. I'm not saying that your 34% is wrong. If you're writing a probability is always out of 1, which is the same as the whole area of the curve. Anyone want to take a guess what the probability would be then?
34 point.
Not 34 hundredths or 0.34. So, what is the probability that the teen sends between 100 and 125 text messages? 0.34. So, probability, teen sends between 100 and 125 text is, I'm going to erase this, 0.34. So this is why I say nothing has changed. The only thing that you have to be aware of with a probability is it's out of 1. It's not a percent of data, it's a probability. Probabilities are what you see in that z-score table. When you put norm CDF in a calculator, you're getting a probability. You can convert it to a percent, but those decimals are your probabilities.
Wait.
What's up?
Yeah.
Okay, what are your questions? You get it, Elijah?
Yeah.
Okay. Can I get someone to volunteer what their group said for part B? Peyton.
0.1615.
Okay, so I think you had originally 16.15, and so you're converting it. So a probability of 0.6 or 0, was it 16?
1615.
Okay. Anybody want to push back on that or add on to that?
How we get it?
That's a good question. We'll answer that question in a second. Does anybody want to push back or add on to that first, though? Yes, Samayan.
Is it not just 0.16? Like, where do you get the 1.5 from? Don't you just...
It's a good question.
Wouldn't they round up?
Okay.
Wouldn't it be
Wouldn't it just
0.62?
not be there?
I would just leave it as the 1.5. We have 4 decimal places, but let's address this idea. Should it be 0.16 or 0.1615? Peyton, what was your reasoning?
Because it's asking for fewer, which means it also means less than 25%, so you have to count the 0.15%.
So I think it's this region, that's, and this region. So 0.135, 0.025. So what did y'all forget if you said only 16%?
0.15%.
That little tail there.
I thought the little segment was 2.35.
It is.
Or 2.35, you're right. So 0.235.
And that would
And
be
then if you
16.
make it 16, it's 16.
2.35. He making it a
No, that is
probability.
0. Hold on.
How about we just start from the beginning?
Yes.
Because that's
Hold on,
still
hold on,
how
hold
we
on.
calculate.
This is 0.025.
Come on.
Okay, hold on. Okay, stop. What percent of data is in between 1 standard deviation below and above? 68. What is the percent between 2 below and 2 above? So let's stop. I see where this mistake is. It is 0.235.
Exactly.
Okay. So look right here. 95% is here. So if I am looking for beyond that on either tail, 100% minus 95% is 5%. Right? The 2.5 would be both of these regions. Right? 2.5%. And all of this would be 2.5%.
Why are you putting it under thousands?
What?
Why are you putting it under
And
thousands?
that's for probability.
Yeah. So probability, remember, is between 0 and 1.
I am not lost.
Okay? Okay, so right here. But does that make sense? So y'all were looking at this section is 2.5? Payne and JD, y'all were looking at just this region as 2.5, but remember that whole tail is 2.5%. Okay? And so that's one of the things, like if you draw it out, it'll help make more sense. But you were right, 0.0235, and then 0.015. Yes, ma'am.
So has it always been 0?
Actually, that should be, sorry, 0.15. Go ahead.
Has it always been 0.5?
Yeah, because if this, so remember, if this in the middle is 95%, on the tail ends it has to be 5%. Splitting it in half, this whole tail is 2.5%. This whole tail is 2.5%. Right? So if 95% is what's in the middle, the whole tails beyond that are 2.5%. So it would not be 0.1615, it would be 0.16. Include more details and justification. But group 5, are we good with that? Yes? Okay. Any questions? And I will point this out, I do want to pause and I want to share this with you. Please note that I did not know that value off the top of my head. There are too many values to memorize. Use your 68, 95, 99.7 to figure it out. Instead of memorizing a whole bunch, memorize and know your 3 from the empirical rule. And that's why when I started working it out, I found my mistake, or I found that mistake. Right? Don't memorize all of it. It's too much to memorize. Know your empirical rules, 68, 95, 99.7, and work from there. Okay? Part C, more than 140 text messages per day. Can we use the empirical rule again?
No, just
Why do we have to use a z-score?
it's less than half.
Yeah, because we can't make another.
It's not an integer value.
That's what we want to recognize. It's not an integer value. It's somewhere around here. Specifically, like as soon as I realize, hey, I can't use empirical rule, it's not an integer value, I'm going to write out my z-score formula, right? And please hear me very clearly. I saw someone else, and this isn't a bad thing, it's a thing to learn from. I saw a student writing this earlier. If you just write this, you can lose the meaning of this. What is this equal to though? Z. That is a constant reminder, should be a constant reminder that what you're calculating is a z-score. We can figure out more from there, but we're calculating a z-score. So what is x, the value? 140, that's how many text messages, minus the mean of 100 divided by the standard deviation of. And so what is that? And I'm going to go ahead and tell you this. This will be on your test. What does that 1.6 mean?
That's the range.
That's
Hold on one second. Hold on. There's this weird thing where Kaya respectfully was talking first, and then some people jumped on top of her. That's not how we operate. We are a mathematical family. We respect our family. We listen to them. We let them talk. All right. So, Kaya, can you tell us what you think it is?
It's approximately, 1.6 standard deviations away.
Okay. So I want to pause and I'm going to give y'all a chance to add on a little bit, but I will point this out as well. Is that an approximate thing? No, that's exact, right? We don't even need to say approximately. But I'm going to repeat what Kaya said, and I want someone to figure out what to add on to it. You said it is 1.6 standard deviations from the mean. Do you know what I'm going to ask for more clarity on?
What do you mean by that? That's what you
Listen to what Kaya said again. It is 1.6 standard deviations from the mean.
What is
What is
1.6?
the 1.6 standard deviation is okay.
It's a 1.6.
What is
This is above.
What is it? Is it?
What is it?
Say again, Max.
What is it?
What is
I
it?
just said it 3 times.
I'm sorry, Anthony. What is it? What is it? You're referring to the. There we go. We need the context. 140. Listen. 140 text messages is 1.6 standard deviations above the mean. How do we know it's above? Because it is positive. Okay, so we need to clarify those details. 140 text messages is 1.6 standard deviations above the mean. That's what that means. We need to be clear with that statement. We don't want to use the word it. If you're ever using the word it, you're losing context, you're going to lose out on clarity of understanding and points on that rubric because it's not 100% clear that you know what's being talked about. So be careful with that. Next thing. Before I jump to a calculator, before I jump to a z-score table, what am I going to use at this point, or what am I going to do? Emma?
Wouldn't you bring over like the 1.6 not make it easy?
What do you mean bring it over? I will say this, hold that thought, because there's something that you're forgetting that I would do as my very next step.
That's probably what
Draw it out.
Say it again, Max.
Draw it out.
Draw it out. I'm always going to draw it out because that's going to help me. Alright, so I'm going to draw this out. I'm going to draw my standard normal curve. I'm going to show my mean. And I'm only even going to focus on what's above because 1.6 is above. So there's 1, same distance, there's 2. And what I'm looking at is 1.6. It doesn't need to be perfect, but it needs to be approximate. And then what am I going to do?
Shade.
Which way?
To the right.
Why?
Because it's positive, because.
Not just because it's positive.
It's
It's more than. Because it could be less than, but I'm looking for more than. I'm looking for this. And that's important. Because I talked about it with at least one group. When you go to the table, the z-score table, is the area on the z-score table to the left or to the right?
To the right.
The z-score table is always the area to the left of that z-score. So go to your z-score table. You got it in your book. What's the area associated with 1.6? 0.9452. Can I get confirmation from each group?
Yeah.
If you're not sure, look on it with your group. Ask them. That's correct. Guy from group 1, everybody from group 1 get there?
Wait. What are we looking for?
I'm looking for the area under the z-score table.
What is Z-score table?
Where's your z-score table?
Well, I wasn't aware of that. So I'm thinking here, I'm like,
Let me see. Stop. Let go. Let go.
So you just got it.
1.6, 0, 0.9425.
Which one is on the right?
Yeah, please note, okay, so this is a good question from Owen. Look, it's an understood 0 here, so when you look at that top row, you want 0.00 as the hundreds. Yeah, there you go. Okay, yes, Madison.
So I got the answer, right? And I multiplied it by 100.
Okay.
When are we supposed to multiply it by 100? Because I was thinking 94 couldn't be this little, little cell.
Well, first off, hold on a second. Are we supposed to multiply by 100?
That's what I'm asking.
We're trying to find a probability, not a percent. We're trying to find a probability. First off, second off, that definitely can't be this little tail.
That's what I was saying. That's what I was saying.
So what do we need to do? We need to subtract.
Oh.
Subtract that from what?
From what?
Nice.
Oh, true.
Notice, remember the table always gives you what is to the left. So to get what's to the right, I got to subtract 0.0548. That, I'm not going to write it out there, but that's what we want to recognize. The probability of a teen sending more than 140 text messages per day is 0.0548. Yes, Tori? No, because we're not doing percent.
Well, did you get the 1 from
Probabilities are added one.
Yes, so remember, probability, if something is never going to happen, the probability is 0. If it's definitely going to happen, the probability is 1. That's a 100% chance of happening. But also it's coming from the fact, what is the area under the standard normal curve? That's why it's 1 minus, because the total area under the standard normal curve is 1, corresponding to those probabilities. Does that answer your question? Destiny? So, remember the area under this entire standard normal curve is 1, right? This, from the z-score table, is what is to the left. I don't want what's to the left, I want what's to the right. So it's kind of the idea that if you take left and you add it to right, it has to add up to be how much? 1. and I know what's to the left is 0.9452, plus that right side has to add up to 1. So if I do 1 minus that, want to give me what's to the right? Does that answer your question? So when you subtract it from 1, that's what's going to give you to the right. Yes?
So you know how you were like, if it's, like with the 1.6, you was like, it's understood to be a 0 at the end, the reason it's 0.00. If it was like a 2, would you go to 0.02?
If it was 1.2,
No, like 1.62.
well, if you go 1.62, you do 1.6 on the column, and on the right, it would be 0.02 to get that 1.62. Answering your question? Okay. Emma?
Can you explain how you got 0.05 for it? Can you explain that?
We got to get moving for the sake of time. I'm going to come to your group first when we go back into small group for the next thing. Okay. So last thing I want to quickly do is this. We also want to know how to do this on the calculator. You will have to do it both on the calculator and the z-score table on the test. You only have to do one of each, and then from there you get to decide which one. But I need full evidence that you understand how to use both. So pick up your calculators. Where are we going to go on the calculator to find this probability?
Calculation.
Once you're under a calculator, you're going to go to menu,
Probability.
either probability or statistics. Okay? And then we're dealing with distributions and normal CDF. You're always going to use normal CDF.
Negative 100 or negative.
Nope. This is why you want to draw it every time. What is the lower bound of the shaded region?
Negative, oh.
That 1.6 is the lower bound of the shaded region, and it's going to the right. So what's the upper bound going to be?
Infinity.
That's a big number. Technically infinity, you could do 100, you could do that 9E999, just something big enough. It really just needs to be bigger than 5 to be real, but 100 is good. What's the mean? Remember, the whole thing is we converted it to z-scores, which is the standard normal curve. So the mean would be 0, the standard deviation would be 1. When you convert it to z-scores, you will always use a mean of 0, standard deviation of 1. And what do you get when you plug those numbers in? Say again? Yeah, that's why we draw it. You see how that shaded region, the lowest part of it is 1.6, but then it continues for forever.
And we just leave it at 1.
See the same answer? Yeah, when you round up, right? Okay. Because right here, you said the lower bound is 1.6. Remember, the lower part is 6. The upper part, because it never stops.
So what's this, like, what's this instrument?
Okay. Alright, really quickly, please listen. Hey, we're going to continue to the next part. Can I get a quick show of hands if you need myself or Miss Estel to show you how to use the calculator when we get started? So I'm going to start answering Emma's question, okay? So I'm going to work with Tori for a second. Anybody else? Daria? Okay. So can you start, Miss Estel, with Tori, and I'll start on the left side of the room, or my left. All right, well, hold on. So we are moving on to activity 4.1. So you have collected data. We're just giving you the information, but you have collected data on the delivery times for 2 local pizza shops, Antonio's Pizza and Wood Fire Pizza. Based on your data, Antonio's Pizza has a mean delivery time of 30 minutes and a standard deviation of 3 minutes. Wood Fire Pizza has a mean delivery time of 25 minutes and a standard deviation of 8 minutes. All right? So
we gotta draw 2 different,
we have 2 different distributions. So you would have to draw both of them, okay? I'm going to go ahead and tell you, for the sake of time, I don't care about number 1. Okay? Start with number 2. Just come up with ideas. We'll talk about it. The focus for this is number 3. Come up with some ideas for number 2. The focus is going to be number 3. Yes, ma'am. Okay, let me work with Emma for a second, then I'll come back and answer calculated questions.
You can make this.
Oh.
It has to be bigger than 5.
Every time I think, oh, that's what I'm like, okay.
I was confused about when I realized there was something like
Okay, so, do you understand how we got that area is all of this, right? What's the total area of that curve? So this is going back to one of these fundamental ideas back here. So this is why you want to go back and look through some of these slides. So over here.
What's it to you?
The area of every standard normal curve, that area underneath is 1, right? Because that 1 is representing 100% of data. So if I take all of this and I add it to all of this, it has to add up to 1. So if I do 1 minus what's to the left,
Okay, that makes sense. Thank you.
yep.
So we just run with this is our only meeting.
For number 2, actively collaborate and discuss, what's that? The one that we just did. So remember, this is why you want to draw it, right? So you actually need to be asking the question, what's upper and lower? We had a z-score of 1.6, right? So just estimating, so roughly here's 1.6. Did we want what was to the left of that or to the right of that? To the right? So what is the lower bound of the shaded region? That's this. You see how it never goes to the left of that? So this is the lower bound. What's the z-score there? When we calculated z-score, right? So 1.6. And then notice, does it ever actually stop going to the right? So technically, it's going to a z value of infinity. You can't put it whenever it's infinity, just put 100. Or if it's negative infinity, you put negative 100. Now, remember, don't hit enter yet, because that's the mean and standard deviation for the original thing, right? But this is a z-score. What's the mean of the standard deviation? 0, right? 0, 1, 2. So when you convert it to a z-score, it's always a mean of 0 and a standard deviation of.
Why did you say 25?
Does that make sense? So that's why you want to draw it, to be able to visually see what is my lower bound and what is my upper bound. And then when you create this, the mean is always 0, standard deviation is always 1. The next time I see that, you're lucky you got this what you did. You're wasting time.
I did it first. That's the best friend to print out a picture of me. All that excitement you came back.
Oh, we got to Antonio and another.
Well, what I would say is, he's right, but I would just draw it out, right? So there's 1 standard deviation, there's roughly 2. So when we go to 1.6, right? We wanted more than 140 ticks, which is more than that 1.6. What is the furthest left that the shaded region is?
Literally the same thing.
So the lower bound is the furthest to the left that it goes. You see how it doesn't go beyond this least? So that's my left bound.
We try to do
Does it ever go to the right? So then, infinity, but you'll typically just put in a
Do you have a lower mean delivery?
my ears.
Lower bound is whatever's the leftmost. And then the upper bound is what's rightmost for the shaded.
41.
Does that help explain it?
I mean, they,
That man ain't gonna get no job.
we're a little bit confused on there because they have the same answer, like if you take, because when I originally.
So just
Oh,
but
you got a dark chart.
that's, but notice, that's the area that's
Very
to the
good.
left.
Look at the chart still.
We don't want that area to the left.
Oh my
So you
God.
did.
What's the probability of building
Mine
those
is
different
35,000. Went up to its high line. I need y'all.
That's over there.
8 divided by 5 is.
The whole thing you're about to do.
Pretty likely.
Germany got
16 in
That-
it. So yeah, and even 8 is 16. Whereas the other one, 3 minutes.
calculator here?
60. So it's only
Start
very.
drawing and answering
So
questions.
I
will say this.
I encourage you to think about this.
You're not necessarily, that's fine. I'm gonna think about it as a standard normal curve, but that's fine for now.
Like 68% of it is getting.
What is the standard normal curve? It's the one with a mean of 0 and standard deviation of 1. The standard normal curve is just when you're dealing with z-scores. The standard normal curve is when you're dealing with z-scores. So remember, the mean would be what z-score? 0. 33 would be what mean, what z-score? 1, and then 2, and then 3, and then -1. And so I would just write my z-scores below it so that I can see what it corresponds to as z-scores. Does that make sense?
We're going into probability and distributions, imaging. So we're gonna do, so check this out, right?
It's just one.
She wanted to.
Can I tell you what I
Can't
think?
be meals.
Repeat.
Can I tell you what I think? In the calculator, can I tell you what I think?
But it's 5 over 3. Right? Right?
I just wrote that down.
Yeah, no. You wanted to stop out at 1.65. Yeah. Three, we're trying to get Z, no, we were getting Z score, right? We're getting the probability. And then we're gonna, we gotta get probability for, and somebody has no and,
I mean, coach me.
okay, I got.
I need no numbers because my brain is.
Thank you.
Okay, Amber.
Thank you. I'm gonna let y'all go back to working. I just want to point something out. First off, because I meant to mention this earlier, I saw this on y'all's graphs before. What do you see above my histogram that you might want to start including?
Title.
The title for the graph. Make sure you're thinking about titles for your graph. You're thinking about maybe even units. All right, these are minutes. Here's one of the things that I do want you to get used to though, because what are you going to convert your values to when when you can't use the empirical rule? What are you going to convert those values to when you cannot use the empirical rule? Z-scores, right? So what I would do if I were you is below your values, I would write my z-scores because then you're converting it to the standard normal curve, right? When it's 21, 24, 27, that's just a normal curve. But when you have your z-scores, the z-scores are based on the standard normal curve. So when I'm looking at the mean, what is the z value? 0. When I'm looking at 33, what is the z? And then below I have -1. Okay.
I mean, I'm sure.
Remember, we just go 3 below and 3 above, okay? So please note, I would note my z-scores so that once I convert to z-scores, it's easier to identify where it is on the curve. For example, when you get down to number 3, she needs the pizza for the party delivered in 35 minutes or less. I need to convert that to a z-score. So what would the z-score be for Antonio's?
1.6 repeated or 5 or 45.
How'd you get there?
I subtract 35 minus 30, which is.
Hold on. What do I recommend that you do even before you put anything into that formula? Write the formula. The more times you write that formula, the better you're going to remember. Okay? So you're not wrong. I would just recommend that. So the value is 35 minus the 30 divided by 3. And so that would be 5/3 or 1.6 repeating. Now we'll point out, which of those is going to be easier to put in the calculator?
1.65. Oh,
5/3, that fraction, right?
Because it's repeated.
Because it's a repeating decimal. And once I have my z-score, that's when I'm going to sketch it on here. I now know 1.6 repeating is right here, roughly. Now it's going to be easier. Now notice I haven't shaded yet. I want you all to continue working. I want you all to finish up activity 4.1. But for your evidence, you should probably draw that standard normal curve or the normal curve with those z-scores associated, because one, it's going to help you study. Two, it's going to be greater evidence when it comes to an assessment. All right, let's finish that problem up and we'll come back together in just a few minutes.
Yeah, I did that. Oh, I know.
So we just make it the same.
So you jacked me up last time. Yes, you did. The last time you told me to put most of my
Because it is that.
Wait, so backwards?
Yes.
Maybe. So let me think on this for a second. So, So what I'll point out is, for Antonio, standard deviation is 1.6 repeating. Right, so there's a lot of probability that it's going to get within 35 minutes. But what's the, so you do this wood fire 10, you do this divided by 8, which would be 1.25. So is there going to be less probability or a higher probability of getting it within 35 minutes? So less probability, so I do it with 10.
What I'll do is
Z-score actually goes that way.
That's what I did. 35. Oh, hold on.
Because there's such a high variability though, I say the higher your spread, okay, you're less likely to get it. You can't just go off the yep. That's exactly, that's the point of this problem.
oh wait, this is Z-score. I thought we put in that.
You are getting the hang of it? I know, it's like, he knows what's happening. He's getting it. Good.
I'm probably getting it.
So what do you do? I would show the shape of the curve, I would show my score and all that kind of stuff.
It's like 1.009.
We gotta explain.
Yes. So, well, in standard deviation gives a spread, right?
Are we doing this wrong?
Because that was smaller.
Standard deviation is measured as spread.
Yeah, I'm doing Antonio.
And so spread and standard deviation go with each other, and so it's something to be aware of. Okay.
They already got it on board.
Yeah.
I thought you were talking about the wrong city.
Let's go.
We'll work out the probability.
Stove wood, you guys? Wood fire?
Hey, you put the air
That's what I got.
Hey, do we have this?
I am on purpose.
Yeah. So wood fire, is 85% or 0.85, not 0.85?
Oh, okay, that's fine. Alright, so the one for,
You sit here doing